Hello students, in this lecture we are going to discuss about the force response of the system which is described by the difference equation. Okay, so this can be explained with the help of an example. So here I am giving one example. Find the force response of the system described by the difference equation and which is given by y of n and plus 2 into y of n minus 1 plus y of n minus 2 which is equivalent to x of n plus x of n minus 1. So for the input which is given by x of n is equal to 1 by 2 whole to the power of n u of n. Okay, so we need to find the forced response, or so its another name is nothing but zero input response. Zero input response sometimes. So we may ask, the question is asked like that: find the zero input response of the system described by the difference equation. Okay, see, in previous video we also discussed that to find the natural response, or we are asked that question is also asked that find the natural response or zero input response. For this question, so find the forced response or the zero input response. Okay, now see how to solve this question. It's the same, just like the same procedure we are performing. We need to obtain the homogeneous equation as like as we are solving in natural response. So we are doing the same way. Okay, so let us consider what is the given equation. Our given equation, y of n plus 2 into y of n minus 1 plus y of n minus 2 which is equal to x of n plus x of n minus 1. This is our given equation. This is our given equation. Okay, now we need to find out the homogeneous equation. Okay, so the homogeneous equation can be determined. The homogeneous equation can be determined which can be is determined by considering this input terms which is equivalent to 0. So then my equation becomes y of n plus 2 into y of n minus 1 plus y of n minus 2 which is equal to 0. So the homogeneous equation can be determined by consider yh of n is equal to lambda to the power of n. Okay, so by substituting y of n as a lambda to the power of n and y of n minus 1 as a lambda to the power of n minus 1 and y of n minus 2 as a lambda to the power of n minus 2, after substituting we are getting the equation lambda n plus 2 into lambda to the power of n minus 1 plus lambda to the power of n minus 2, okay, is equal to 0. Okay, now by taking lambda to the power of n minus 2 is a common, lambda to the power of n minus 2 is common. So what is our equation? By taking as lambda to the power of n minus 2 is common, and we are getting the equation lambda square plus 2 into lambda plus 1 which is equal to 0. Okay, and this equation becomes 0 by putting outside, so that's 1. And our remaining equation is that lambda square plus 2 into lambda plus 1. This is our polynomial equation, second order. This can be written as lambda 1 plus lambda plus 1 whole square is equal to 0, and we can solve as we are getting the equation, the roots are lambda to the power of minus 1 Okay, lambda 1 is minus 1 and lambda 2 is also minus 1. This is almost similar as the natural response up to where here. So here the roots are repeated. So the roots are repeated. So what should we do? So because of the roots are repeated, this homogeneous equation yh of n can be written as c1 minus 1 whole to the power of n plus c2 n into minus 1 whole to the power of n. So this is our homogeneous equation. This is our homogeneous equation. Okay. Up to this, okay, we 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 repeated the same procedure as like as in our natural response. Okay, but from now onwards, okay, what happened? So the solution is completely changed. Okay, for after getting the homogeneous equation, now we consider the input. For which input, according to the problem, the input is given by x of n. X of n is equal to, what is input are given in the problem? 1 by 2 whole to the power of n and u of n. Okay. For this input, the particular solution, we need to find the particular solution. We need to find the particular solution. Okay. For this input, the particular solution which should be right. So we have different types of inputs are there. So we have different types of inputs are there, and for different inputs, there are different types of forms are there. Now I'm going to discuss about those inputs. Okay, so this is x of n. This is input signal, and this is yp of n. That is a particular solution, particular form. You need to remember these forms. Okay, depends upon the type of input, so our particular solution is also gets changes. Okay, if input is a step input, that is a, if input is step input, okay, so then the y particular solution is nothing but k only. If input is in the form of a into m to the power of n, then my particular solution is given by k into m to the power of n. If input is in the form of a small n to the power of capital M, then my particular solution k naught into n into capital to the power of m plus k1 n into m to the m minus 1 and so on km. This is my particular solution. This is my particular solution. Okay, so this predefined. So if my input is in the form of a to the power of n and capital N to the power of m, then my solution, my particular solution is in the form of, it should be in the form of a to the power of n k naught into n to the power of m plus k1 n to the power of m minus 1 and so on km. This is my solution. If particular, so if input is in the form of a cos omega n and a sin omega n, okay, whatever it may be, then the particular solution is given by c1 cos omega n, okay, plus c2 sin omega n. Okay, so here once again it is very important. So when the input is in the step input, when the input is in step input, you need to define the particular solution in the form of, okay, so if input is in the a step input signal, you need to write the particular solution is k. You need to write that particular solution is k. Okay, according to the table, according to this, based on this table, we need to identify the type of input. Okay, so here our input, what is our input? Our input is given by, once again I'm writing here, our input is given by, okay, x of n is equal to 1 by 2 whole to the power of n into u of n. Okay, so for that, so what is, so this is a input signal. This is our input signal. So for that, see, observe, so here step 6, step input. So what should we do? You need to the particular solution to in the form k only, okay, so that's why the particular solution is in the form of, so the particular solution the particular solution is in the form of is given by y particular solution yp of n is equal to k into 1 by 2 whole to the power of n u of n. 1 by 2 whole to the power of n u of n. Okay, so this is very important step, students. Okay, so far we did we are finding out the homogeneous equation. After that, after finding out the homogeneous equation, now according to the type of input you need to determine the particular solution general form. So here this is most important. If you are failed to find this particular solution of the form, then your entire answer should be is going to be wrong. Okay, so be cautious. So according to the type of input, you should write the y particular solution. That is the most important. Okay, once you define this step, once you should write this y particular solution of the form, then the rest of the process is similar, very same and very simple also. Okay, so we will see how to solve this y particular solution. Okay, so here just like similarly substitute after getting the y particular solution, after getting the y particular solution, now substitute. Okay, this yp of n particular solution and x of n solution in the difference equation. Okay, in the difference equation, so we get one general equation. Okay, what is our equation? The difference equation, once again I'm writing here. So our differential equation is given by y of n 2 into y of n minus 1 plus y into n minus 2, which is equal to x of n plus x of n minus 1, x of n minus 1. Okay, now substitute y particular solution. What is our y particular solution? So this is k into 1 by 2 whole to the power of n plus 2 into k into 1 by 2 whole to the power of n minus 1 plus k into 1 by 2 1 by 2 n minus n sorry whole to the power of n minus, because of in the form. Okay, what is our x of n? X of n is given by, x of n is already defined as 1 by 2 whole to the power of n. So we need not to consider k. This is one more important step. Okay, our input is given by x of n is given by, input is given by 1 by 2 whole to the power of n. This is given in the problem. This is given in this problem. Okay, so this is given in this problem. Our input is given. Okay, so no need to consider k. Okay, so please don't confuse. Okay, so here our input is 1 by 2 whole to the power of n. Okay, for this case x of n minus 1, that is 1 by 2 whole to the power of n minus 1, n minus 1. Okay, so by substituting a value which should be give the way as what is the case here? By substituting the value for n in order to give the none of the terms gets vanished. Okay, so ఒక వాల్యూ సబ్స్టిట్యూట్ చేసుకున్న తర్వాత ఆ టర్మ్స్ ఏ వాల్యూస్ కూడా మనకి ఇక్కడ వానిష్ అవ్వకూడదని, దట్ ఈస్ ద వాల్యూ. సో ఇఫ్ యూ చూస్ డైరెక్ట్ లైన్ ఐఎమ్ సింప్లీ సబ్స్టిట్యూటింగ్. ఇఫ్ యూ చూస్ n is equal to 2, so the way the no term is going to be vanished. So after substituting the value of n is equal to 2, we get k into, so 1 by 2 whole square plus 2 into k into 1 by 2, 2 minus 2 to the power of 1, 2 minus 1, that is 1, and k into 1 by 2, so 2 minus 2, that is equal to 0 by subtracting. Okay, so that's it. And 1 by 2, so here also n is, what is the value of n? N is 2 plus 1 by 2, 1 by 2, 2 minus 1, that is 1. Okay, now see, its value is equal to k into 1 by 4 plus this 2 gets cancelled and the value is equal to k, and this is k by 2, which is equal to 1 by 4 plus 1 by 2. 1 by 4 plus 1 by 2. Okay, after solving this equation, so we are getting the value of k. K is equal to, what is the value? By solving this value is equal to, k is equal to 1 by 3. Okay, so this is k value is equal, given by 1 by 3. Now we are determined the y particular solution. That particular solution is yp of n. Yp of n is obtained 1 by 3 into 1 by 2 whole to the power of n. So this is y particular solution. Okay. Now we need to find out the forced response. Okay. So the forced response. So here, so we are getting the forced response. Now we need to find out after finding out the y particular solution. Now we need to find out the forced response. So y forced response, y of n, which is equivalent to, okay, y homogeneous equation yh of n plus yp of n, yp of n. So this is one more important step for to determine the forced response. Okay, so here y forced response is given by, y forced response is given by, what is yh of n? Yh of n is already determined in previous steps. Okay, c1 into minus 1 whole to the power of n. Okay, and c2 into n into minus 1 whole to the power of n, and just now we determined the value of yp of n, that is 1 by 3 into 1 by 2 whole to the power of n. Okay, this is the equation. Okay, and now we need to solve this equation. How? Okay, now by substituting n is equal to 0, in the above equation, okay, now I get instead of y of n, I am writing as a y of 0. Okay, and we get c1 minus 1 whole to the power of 0 plus c2 into 0 into minus 1 whole to the power of n plus 1 by 3 into 1 by 2 whole to the power of 0. So this equation becomes 0. So I get to y of 0, which is equal to c1 plus 1 by 3. Okay, so this is one equation. Now at n is equal to 1, by substituting n is equal to 1 in this equation, okay, now we will see again the equation can be written as y of n is equal to this is c1 minus 1 whole to the power of 1 plus c2 into 1 into minus 1 whole to the power of n plus 1 by 3, okay, 1 by 2 whole to the power of 1. Okay, now this is the y of n becomes minus c1 minus c2. So here, here minus plus 1. Okay, minus c2 and plus 1 by 6. Okay, so this is another equation. We get this another equation. If you determine the values of c1, c2, so then our problem is over. Okay, how can we solve these equations? So if you want to determine these equations c1, c2, again you need to consider once again the differential equation. What is our differential equation? The difference equation, what is our given by? Okay, so what is our differential equation? It is given by y of n plus 2 into y of n minus 1 plus y of n minus 2, which is equal to x of n plus x of n minus 1. Okay, now see, if you substitute in this differential equation n is equal to 0 in this equation, we get the term y of 0 plus 2 into y of minus 1 plus y of minus 2, which is equivalent to x of 0 plus x of minus 1. Okay, so here in this problem there is no initial conditions are there given. Okay, so that's why y of minus 1 is 0 and y of minus 2 0. So these two values are equal to 0. Okay, now so why? Because we are finding out the forced response. In that forced response, so there is no initial conditions are existed. So that's why I'm going to write directly this y of minus 1, this y of minus 2 is equal to 0. Okay, now what is the remaining terms are there? So the remaining terms are there y of 0, which is equal to x of 0 and x of minus 1. Okay, clearly, so here remember what is our x of n? X of n is nothing but 1 by 2 whole to the power of n u of n. So this is step signal. So this is what? This is step signal. Okay, so how a step signal is looks like this in discrete time signal. So the step signal is like that. It is different as so x of n is equal to 1 and n is greater than equal to 0. Okay, it is 0 for n is equal to n less than 0. Okay, so all magnitudes are 1. That's it. Okay, that is the basic definition of step signal. So here we are the step signal which is multiplied with this 1 by 2 whole to the power of n. So the magnitudes of the step signal is 1 by 2 whole to the power of n. Okay. Okay. So here what is the case here? So y of 0 which is equal to x of 0. What is the magnitude of x of 0? So x of 0. So according to the definition of step signal, x of n is equal to 1 by 2. X of 1 by 2. Okay, whole to the power of n when n greater than equal to 0. Okay, x of n is equal to 0 when n less than equal to 0. When n less than 0. This is very important, students. Just remember, x of n is equal to 1 by 2 whole to the power of n when n greater than equal to 0. 0 when n less than 0. Okay, so here x of n is 1 by 2 whole to the power of n greater than equal to 0. Clearly it satisfies this condition. Okay, so what is the case here? 1 by 2 1 by 2 whole to the power of 0. Why? Because n is equal to 0. That's fine. What about x of minus 1? Clearly x of n is 0 for n less than 0. So its value is equal to 0. X less than 0. Most of the students they confuse it here only. Why? Because they're simply substituting n values in this equation, and finally after substituting and they're posting the results, and those results are wrong. Okay, so here, so once again I repeated, most of the students they made mistakes, they make a mistakes here only. Okay, but because here the reason is that they are x of 0 after doing all these things correctly. At the time of finding out the y of 0 and y of 10, here there is a making mistake once again. Okay, now so x of 0 x of n, simply they substitute the values of n is equal to 0 in this x of n, and finally they posted the values. It's completely wrong. We need to understood the step signal. We need to understood the input condition. We need to understood the input condition. Okay, according to the type of according to the input condition, we need to consider those values only. Okay, so that is very important. Okay, now remember. Okay, that is the most important. That's why only I want to highlight this point. Okay, so here y of 0 is equal to 1 by 2 whole to the power of 0. Its value is equal to what? Its value is equal to 1. Its value is equal to 1. Okay, it's not 1 by 2. Okay, so here 1 by 2 whole to the power of 0 again. Okay, some of the students they're confused here, so they made 1 by 2, so that's why they posted 1 by 2. Again they get the values are they will get the wrong values. Okay, and next, okay, after finding out the y naught of value, now we need to determine the y of 1 value. So by substituting n is equal to 1, and again we get y of 1 plus 2 into y of 0. Okay, and plus y of minus 1, and which is equal to x of 1 plus x of 0. Okay, how it is getting this equation? The simply put substitute n is equal to 1 in this in the differential equation. Okay, so just now we determined the value of y naught. Okay, so here y of 1 plus 2 into y naught. Y naught value is value 1. Okay, so 2 into 1. Okay, clearly there is no initial conditions are existed. This value is equal to 0, so we can write directly 0. Okay, again x of 1 x of 0, x of 1 x of 0. Okay, that is very important. Okay, what is the case? X of n, so according to the definition, okay, x of n which is equal to 1 by 2 whole to the power of n. Okay, and what is the condition? What is the condition here? If n is greater than equal to 0. Okay, if n less than 0, what is the value of x of n? X of n is equal to 0. Okay, so here, so n greater than equal to 0, n greater than equal to 0. When n is equal to 1, it is 1, so 1 greater than equal to 0. So that's why we need to write 1 by 2 whole to the power of 1 plus x of 0. Again, it satisfies the condition. So 1 by 2 whole to the power of 0. Okay, so y of 1 plus 2, again 1 by 2 plus 1. Okay, so by determining y of 1 is equal to its value by solving minus 1 by 2. Okay, so this is another value we got. So we determine y naught value, and we determine y of 1 value. Okay, After substituting all these conditions, already we determined the equations in the equation. What is the equation? Okay. Once again, rewriting this equation. So y naught is equal to c1 plus 1 by 3, and y of 1 is equal to minus c1 minus c2 plus 1 by 6. Okay. So by posting what is the value here? We are getting y naught value. Y naught value. What is the value of y naught value? So y naught value is equal to what is the value of obtained? 1. Its value is equal to 1 is equal to c1 plus 1 by 3. Okay, and finally we obtain c1 is equal to 2 by 3. So its value of c1, that is equal to 2 by 3. 2 by 3. Okay, and we determine y of n value. So here y of n value already is there. So minus 1 by 2, and just now we determine the value of c1, that is equal to minus 2 by 3, and minus c2 plus 1 by 6. By simply simplifying this equation, and we get the c2 value. Okay, and the c2 value is equal to 0. By solving this equation, c2 value is equal to 0. Okay, so finally we determine the values of c1 and c2. Okay, so finally the forced response. So the forced response is there. The forced response of the solution, it is given by y of n is equal to, what is the forced response? It is given c1 into minus 1 whole to the power of n plus c2 into n into minus 1 whole to the power of n plus 1 by 3 into 1 by 2 whole to the power of n. Okay. Now by substituting the c1, c2 values, we hear the y forced response. Y forced response is given. Y of n is equal to, what is the value of c1? c1 is equal to 2 by 3, 2 by 3 minus 1 whole to the power of n. What is the value of c2? c2 value is 0. Okay. So 0 into n into minus 1 whole to the power of n, and the value 1 by 3, 1 by 2 whole to the power of n. Okay. And finally, our forced response, the forced response is y of n is equal to 2 by 3 minus 1 whole to the power of n plus 1 by 3 into 1 by 2 whole to the power of n. So this is our forced response of differential equation. Okay. Okay. So one more important point is there. One more important point is in questions, it can be noted as a note. Okay. Under the note, if you want to determine the total response of the system, the total response of the system, which can be determined as y of n is equal to y natural response yn of n plus y forced response. Okay, that means you need to determine individuals of y natural response and y forced response. After getting the individual results, y natural response and y forced response, and finally combined together, that is our total response of the system. That is our total response of the system. Okay, that is. Thank you.